Alright guys, welcome to Chapter 3, Taking Control. This should, theoretically should, be a short video. The chapter is pretty good. I mean, we're only talking about loops. You probably have seen these in other coding languages, and your book provides plenty of documentation. So, let's move. So, iteration is moving through a collection. Now, in the last chapter, we talked about arrays and dictionaries. At the very end, we used a for in loop to kind of spit out the content of all the array or all the dictionary. So when we go through that process of giving all the information or of stepping through the array or through we call that iteration. Now with Swift, you can also move a specific distance. And you can do it the traditional way that we'll talk about in just a minute. Or you can do it like in the new Swift way. And the new Swift way is to put 3 dots and then put your first and last number on the both sides. So theoretically, if I wanted my loop to run 10 times, I could do for, name of my loop, in, and then space 1 dot 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 10, and that tells it, hey, run 10 times. And then the stuff inside my loop would go off 10 times. So if any of you guys have a background in C or any C-related language, you may be doing it another way, but this is just a new way that was introduced with Swift. Alright, so what is this? If I do var loop counter colon integer equals 0, what am I trying to do here? Well, this is an explicit variable creation. So in other words, I'm telling Swift, hey, when I make var loop counter, I'm going to start it at 0 and make that 0 an integer. The loop counter is going to be an integer, not a double, nothing else. Now, there's 2 schools of thoughts on this. Some people say you should be very specific in your coding, and you should declare explicitly any variables that you create. Other people say, hey, if it's going to work fine, and there's really not a chance of that being changed, why add extra, coding to it? So I could do var loop counter equals 0, and it would still make loop counter an integer because 0 is an integer. So either way is fine. For any project in this class, you can do it either way. If you want to do explicit variable creation or you just want to do var loop counter equals 0, either way is fine. Just be aware of it in case you see the colon integer or colon double or something like that. That's somebody being explicit to make sure that the code reads the variable as the type that they specifically want. Alright, so this next example is from page 58 in your book. So if I do var, and I should really change this to just like var counter, so this is not a big word there, but var loop counter colon integer equals 0. So now I've created a variable called loop counter, and it's an integer, and I've set the value to 0. Alright, and then I have to put my for in loop, so for loop counter in 1 triple dot 10. So it's going to run 10 times, and that's going to do this. It's going to print line and start with the loop counter, and then it's going to say times the loop counter equals whatever the loop counter times loop counter. So what should happen if you enter this line of code, it should say, 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9. So it goes through the entire loop, 1 times, 2 times, 3 times, 4 times, 5 times, and then multiplies it by itself and then gives you what the multiplied amount is. So just make sure that you remember the triple dot with the number on the left, number on the right. That tells the loop exactly how many times to run. Now, you can change that up and do it a little bit different. In this case, I got for loop counter in, and now I have 2 dots and a less than sign 10. Now, whenever you have 2 dots and a less than sign, it means do this 1 less time than the number on the right. So this would only run 9 times and not 10. So if I wanted to run 10 times, I could do that. If I want to run 9 times, I could do that. And we typically see this used with arrays. Remember arrays, if I have 10 items in my array, they're numbered 0 through 9. So if I do this, theoretically, I should see every value in my array. I just need to make sure that instead of doing 1 double colon less than 10, I do 0 double colon less than 10. And that would show me my values in my array. Alright, if you're familiar with any of the C languages, We typically did our loops like this. We did for, and then we did an initialization, an evaluation, and a modification. So we did something like for loop counter equals 0. That's where we initialized loop counter. And then we did a semicolon, and then we did loop counter less than or equal to, or however we want to do it. But in this case, it's just less than 9. So that's the evaluation. As long as the loop counter is less than 9, I'm going to keep running this loop. And then we have loop counter equals loop counter plus 2, because we have to keep modifying the loop counter for every step of the loop so that eventually it'll run out. So sometimes you'll see it like this, x equals 0, x less than 9, x plus plus. So that's the traditional method. So that's how we control our loops in the C languages. Just make sure that you're good with, the initialization, evaluation, modification. Obviously, this one is the initialization, this is the evaluation, and then this is where I modify the value so the loop keeps incrementing 1, so the loop would eventually count down. All right, and instead of doing loop counter plus 2, we can typically do shorthand. You see shorthand here, x plus plus. So if I do plus equals, it means add the numbers together. And if I do minus equal, it means subtract the numbers. If I do plus plus, it means add 1. If I do minus minus, it means subtract 1. Equals equals means it equals. And then exclamation point equals means does not equal. So using these in code, if I did x plus equals 3, it would add the two together. If I did x minus equals 3, it would, remove 3 from x. If I do x plus plus, it adds 1 to x. If I do x minus minus, it subtracts 1 from x. If I do x equals 5, or x equals 5, it means that's a Boolean statement. Does x equal 5? In that case, it would be false. Or, well, you get the idea. And then does not equal. So exclamation point equal means does not equal. And we'll see this later on in some code. Now, the one thing I want to bring out is the plus plus and the minus minus. The add 1, subtract 1 does not occur until the end of the line, when the end of the line is processed. So if I did, x equals 5, and then I did x plus plus, in the REPL environment, it would still say, x equals 5. Because I have to wait till I enter the next line or till the x plus plus line is totally done before it adds the 1. So to fix that, I can add the plus plus to the left side of the number, and that'll add it right away. So if I did, plus plus x, that would automatically add 1 right away, and then the rep environment would show me that was 6, assuming x equaled 5. All right, so what does that look like? Looks like this. So var my number equals 2, my number plus plus. So if you do this in the REPL environment, which is just the terminal, it'll say, my number equals 2. It won't add the number. But if I did plus plus my number, then it would show up right away. So just make sure you're aware of that. And the purpose of that is, when I go back to the traditional way of doing stuff like this, if x equals 0 and I added this 1 to it right away, I would already start at 1. But because of the way this is written, where the xx is on the right side of x is 0, and I don't add the 1 until after the first iteration. So that's why the 1's not counted. I don't add the 1 until after that line is done processed. If I wanted to add right away, I needed to put it to the left side of the x. All right, and I hope now you're totally confused. All right, so you've successfully passed the terminal portion of the class, and now we're moving on to Xcode. So I think starting at this point on, almost everything we do, we're going to do in Xcode. So you'll make a playground, and you'll just start typing the code, and you can actually save me the playground file. Just zip it up, and you're good. All right, so when you follow the book, you open up the playground, it looks like this. So your code happens on the left, and then whatever your code would display to the screen shows up here on the right. And that way you can quickly check to make sure your code is correct and it's displaying correctly and formatting correctly. So this week, if you want to do your lab in the playground of Xcode, you can. Just make sure that you zip the folder that it's stored in, and then you submit the zip folder. All right, so this week you got a little mini project to do. You need to write, this is half a page. I need at least a paragraph, 4 or 5 lines that tell me what is cocoa. So when we're talking about Apple, what is cocoa? The first one of you guys that talks about Nestle Quick and how great it is and how it's awesome cocoa, it's going to get in trouble. So how does cocoa apply to Apple? What does that do for us in the iOS? And then you'll see a Dropbox that says, submit cocoa assignment page here. All right, commenting. And you should document what things you do in your code because it makes finding things easier. It helps for anybody else to be able to look at it. So anything behind 2 forward slashes is ignored by the compiler. So if I just want to do a quick line that says, hey, this array holds, my recipes or something like that. I would do forward slash, this array holds blah, and then the line would go green in the code, and that means it's a comment and it will not be read by the compiler. But people looking at your code to figure out what it does and whatnot, it would help them out immensely. Now you can do a block of code. Well, let's say I got 14 lines of code and I don't want to comment, or I want to comment them all out, but I don't want to sit there and do double forward slash, double forward slash, double forward slash. I can do a forward slash with a star at the beginning and then a star and a forward slash at the end, and that would comment out the entire 14 lines. So from this point on, make sure you put at least one comment for each item that you're doing. If I ask you to, print something out 10 times, do forward slash, this next bit of code will print my name 10 times or whatever. Just to get in the habit of the commenting thing. All right, Boolean. Boolean is a true or false. And there are 2 specific operators that we talk about when we're dealing with Boolean. And the first one is equals equals. 1 equals equals 1. And that would be marked as true because 1 is equal to 1. Oh. Now, if I do 2 and then exclamation point equals 1, that means 2 does not equal 1. And that would be true because obviously 2 does not equal 1. If I do 2 is greater than 1, we know that's true. And if I do 1 is less than 2, we know that's true. So any of these expressions will show up as true in a Boolean expression. So a lot of times in our decision making, our if-else then statements, in our loops, we will sometimes use Boolean and say, hey, as long as this is true, keep doing it. And we keep doing it until it's false. All right, if we're making decisions, we typically use if-else statements, but there's also another one we can talk about, or we're going to talk about in just a minute. But first, let's talk about if-else. So the if-else statement just reads, if this condition is met, do this, else do this. You can have multiple ifs, you can have multiple elses, you can have all ifs with no elses, you can have multiple if-else, if-else, you can have an if-else in an if-else. So there's all kinds of combinations. So if you've got 4 choices, you can do if this, else this, else this, else if this, that kind of stuff. So anytime where there's a decision to be made, I guess you need to decide whether you're going to use an if-else statement or a switch statement that we'll talk about here in just a minute. So moving on, I could do something like this. So I could have multiple, just the top 2 if statements. So if number is greater than or equal to 3, go crazy. If number is greater than or equal to 2, dance like a madman. Else, eat peanuts. So what number would make me eat peanuts? So if I'm going through the line of code and I type anything other than 0, 1, or a negative number, it's going to either meet the first condition or the second condition, and I won't eat peanuts. So you can phrase your if statements and your else statements any way you want. You can have like 4 if statements, you can have an if and 4 else statements, but the recommended method is, if this, do this, else if, do this, and then end it with an else. So, and remember, we typically only do the if-else statement if there's like 4 or 5 choices. If there's more than that, we go to the switch case statement that we'll talk about a little bit later. So when we do if this, then this becomes the predicate. So if light equals red, then do this, else do this. So light equals red would be the predicate. Now, do normal coders stand around and say, hey, what a big predicate you have? No, they don't really do that. But there are some, I don't want to say weird people, but there are some people that have gone to, I don't know, places where they're very technical and they use the exact terminology for everything. And you may hear that word used. So that's where predicate actually comes from, or where it's at. All right, so something like this, var number 1, colon integer equals 33, and var number 2 equals 101. So my predicate would be number 1 greater than or equal to number 2. So in this case, if number 1 is greater than or equal to 2, I would do this. Else, I would do this. So in this case, I would do this because 33 is less than 101. So remember, we typically use if-else statements if we have 4 or 5 choices. Any more than that, we go to something else. So you can have several ifs in a row. You can have as many if-else or else ifs as you need. You can put the curly braces where you like. Some people put the curly brace here. So if number 1, blah, blah, they put the curly brace here, and then they do the condition. Other people drop this curly brace down a line, and then they have a curly brace, the condition, curly brace. So as long as the code runs, that's all I'm concerned about at this point. We can work on style and formatting stuff later. All right, so if you have too many if statements, we typically use the switch case. And if you turn to page 72 in your textbook, almost there, there's a picture at the top, and then they show the switch case statement. So the switch case statement just says, hey, I'm going to give you a whole bunch of different cases, and the one that matches, that'll be what I do. So in this case, if tree equals oak, I'm going to print furniture. If tree equals pecan, I'm going to make a pie. And if tree doesn't equal either of these, it's just going to print out wood. So it's a lot shorter method for doing if you have multiple things. Like, what if I was doing, states? So what state are you from? And I had to do, all 50 states. I would just do case statements. So case, Ohio, case Pennsylvania, case Indiana, that kind of stuff. Because there's a lot less to write. So switch case, here's another example. Let some character as equals e. So then I do a switch statement. So switch if some character equals one of these, then do character is a vowel. Or if there's a case where the character equals one of these, print it's a constant. And then I put a default at the end in case one of these other cases didn't match. So it's kind of like a catch-all at the bottom. So what if somebody did, hey, put a number in between, 1 and 10, and they put in 25. Or it said, enter a letter from the alphabet, and they put in 12. Then, it is not a vowel or a constant. You're stupid. Please pay attention to what's said. But that's how case works. We just give them all the individual options, and then whatever their item is, whatever option it matches, that's what we do. So it's a lot simpler. Here's another way to look at it. So in this case, var, so I create a var or variable named value, and I assign it a value of 4. And then I just do switch value, and in that case, case 1, it's going to print 0. Case 2, it's going to print. So if value is 0, print 0. If value is 1, print this. If value is 3, so obviously value would equal 4, so I'm going to print out 4. But I typically always end it with a default, and that way, if I say, hey, enter a number between 1 and 10, they hit 25, that kind of covers that. So it's kind of a way to test out or to handle input that's not expected. Now, if any of you guys are coming from a C language, Objective-C, C++, that kind of stuff, you'll notice that we don't need break statements. We don't need break statements with cases. So if this was C++, it would be case 0, print line, break. Case 1, print line, break. Case 3, case 2, print line, break. There would be a break after each print line word because that would break us out of the thing. But we don't need to do that with Swift because with Swift, it's automatically assumed that if something matches, you're going to break out of the statement. So just another cool thing about Swift. So remember, you can have as many cases as you need. If you need 50 or 100, blah, blah, you can all do that. And you don't need a break after each option. And that default at the end is kind of a catch-all. It's typically used for if the user did not input the type of code you expected to spit something else out like that. All right, so loops. We've already talked about the for in loop. So now we're going to talk about the while and the do while. All right, the while loop is pretty simple, and it just starts out with while this condition is not met, or while this condition is still true, then do this. And then we put the do this in curly braces. So while n is less than 1,000, multiply n times 2. And then it'll keep running this loop until n hits at least 1,000 or more. And as soon as this condition, n is no longer less than 1,000, so as soon as that condition is false, it stops the loop. So while loops are pretty common. The two biggest ones you'll do are for in and whiles. And then the last one, here's another example of a while loop. So we do count equals 0, while count is less than 20, do this. And this says print out the number, so it starts with 0, so it would print out 0. And then count equals count plus 5. So this would print 0, 5, 10, and 15. It would not print 20 because once count hit 20, and then the loop would process, count would no longer be less than 20. It would now be equal to 20. So the loop would then stop, and it would process the next line of code underneath these curly brackets. So the loop only runs as long as the condition is true. Once the condition is false, count no longer equals or less than 20, the loop is then stopped, and then we process the rest of the code. So the other loop is the do while loop, and we typically don't do while loops, and the only reason is do while loops have to run at least once. So in this case, m equals 2, and then we do this while this is the condition. So m equals 2, do m times 2, so 2 times 2, while m is less than 100. But if, let's say this condition was while m is less than 2, do it. You can see m equals 2, do it. I would do 2 times 2, and then the condition would say while m is less than 2. So now the condition is not met anymore. So then I would move on and get out of the loop. So you see that it's still processed one time. So that's why people tend to stay away from the do while loops. A do while loop always has to process at least once. So it's just do, and then what you want it to do in curly brackets, curly braces, however you want to say it, and then the condition at the end. All right, here's another example. So while flag equals 1, do this. So I would print flag, then I would add 1 to flag, and then while flag divided by 2 does equals 0, the remainder equals 0, I would run it again. So this would print 1 and 2. And then after that it would stop. All right, moving on. We can combine if, case, and loop statements all together. So while some condition is meant, do this. And then when I say do this, I would say, hey, if another condition is met, do this. Else, do this. So in this case, I've got multiple conditions all wrapped up into a big nested statement. So we can have if and case statements inside loops. We can even have loops inside loops. And when we do, we call that a nested loop. So for an example, let's say you've got an array of 10 values, and you want to compare each value in that array to see if it's a prime number. So really, you need to do two things. You need a loop to go through each value of the array. And then you need a loop to compare that new value that you're looking at to see if it's a prime. So I need to go to value 1 in the array, and then I need to compare it to see if it's a prime. Then I need to go to value 2 in the array. Then I need to see if it's a prime. So you need a nested loop. You need a loop inside of a loop. And then here's an example. So there's a for in loop here that kind of runs through the array 2 through 101. And then once you get inside there, there's another for in loop that says, hey, take each variable, and if it's dividable by 0, it's not a prime number. Else, it is a prime number, or in this case, if. So that's a loop inside a loop, and we typically see those in arrays, dictionaries, that kind of stuff, especially arrays, and we call that stepping through the array. So for some reason you need to get out of a loop. You can use break or continue, and they're a little bit different. Break will actually take you out of the loop. So once I hit a break, the loop is done, and I then process the rest of the code after the loop. If I hit continue, I stop the current iteration of the loop, and then I continue processing the loop as normal. So let's say the loop is going to run 10 times. So the loop is run once, it runs 2, it runs 3, it runs 4, and then it runs 5. And on the 5th iteration of the loop, I hit a continue. So something got met, and then I had a continue. So I would do whatever that condition did, and then I would stop the loop at 5 where I hit continue, so I wouldn't need to process anything else in that loop. And then I would start the loop all over again at the 6th iteration of the loop. So it doesn't take me out of the loop, it just takes me out of the current iteration. So if I've got this big long, if this, then do this, and else this, or else this, let's say if the very first if this, then I said continue, I would stop and not process the rest of this loop. I would just go back up here a while and keep running the loop as normal. So continue stops the current iteration of the loop and then starts the loop back where it was at. And then break actually takes me out of the loop. But don't mistake, like continue does not restart the loop from scratch. It would end, iteration 5 and then start iteration 6, if that makes sense. All right, so if I'm making decisions, I can either use the if-else statement or the switch case. If I just have a couple options, we typically use if-else. If I have more than 4 or 5, we typically use switch case. And then loops, we have 3 main loops: for in, do while, and while. And then for in and while are the most popular. And the reason do while is not because sometimes you don't want a loop to ever run for some reason, and do while always runs at least once. All right, so when you're coding, you need to think of it as a puzzle. I need to break each item down into its individual task, the smallest piece that I can do. Don't try and do 2 things with one code group. So this was always tough for me, like my first time when I had to go through an array and find the prime numbers. I tried to do it with one code group, one piece of code. And you can't, because it's 2 pieces of code. One loop to go through the array, and then one to compare each number to prime. So what you need to do is try to say it in English what you're trying to do. So if I want to go through an array and see if there are repeats, or anytime I use and, but, or, then that typically means I need to add a new line of code, a new code group. All right, so that wraps it up. Again, this chapter is pretty self-explanatory, and there were lots of coding examples in your book. I'm not going to do a coding example video because it's just another video for you guys to watch, and it would just be the exact same repeat of the stuff in the book. But if for some reason you want to see some coding examples and you don't understand something in the book, drop me an email, and I'll either email you back or I'll make a video to show you what you're struggling with, and we'll go from there. So this week you've got 2 projects. There's a coding project where you have to do a couple things. You've got to make a couple loops, print out your name 10 times, things like that. And then you have the mini project where you're going to figure out what Cocoa is, and you're going to submit it in the Dropbox. And I think that about wraps it up. So don't forget, if you have any questions, make sure you email me.